Hello class. Once again, this is Mr. Miller with the GeoGebra construction I'd like you guys to go through. So, the first thing I want you guys to do is we have to create a right triangle. This whole, well, there's the bell. This whole little course is going to be on right triangle similarity. So, first thing we need is the side of the triangle. And then we need to create a right angle with a perpendicular line through a point. You throw a point onto this side, and now you can create a right triangle. Okay, so as always, you should make sure your triangle passes the wiggle test. GeoGebra is very nice that when an angle is right, it makes a little 90-degree mark. So I can now wiggle my triangle and it maintains that 90-degree mark. So it is in fact a right triangle. Make sure you can wiggle all 3 points and then it stays right. So that's one way of doing a right triangle. Another way, which I think is a little bit more aesthetically pleasing, is to create a circle, create a diameter, which is the connection of 2 radii in the same on the same line. And then you're going to create a triangle where one of the sides lands on the circle. Okay. Now, if you go measure this angle is 90 degrees, no matter where it lies on the side of the circle. No matter how big my circle is. So, passes the wiggle test. Once I have a right triangle, that's really what I need. That's where I want to start. So I'm going to hide everything else. I'm even going to hide that point. So, now what I want is I want to look at the height of this triangle. And the height of this triangle, this is our vocab word of the day, is what we call an altitude. So we need to have a perpendicular line to our hypotenuse through the right angle. Okay? You'll notice, since I made it perpendicular, we can go ahead and measure this as well. So, hold on one second. One of your fellow students just came up. Alright, so what we're going to do is I want you to then look at the relationships of these 3 polygons, these 3 triangles. Okay, we've got the small interior triangle. Okay, so the small interior triangle I'm going to make purple. The large interior triangle I'm going to make green. And I'm going to leave the outer one that kind of maroon color. So, if I just look at the outer one, that's my large, the large interior, and the small interior. Okay, so what I want you to do is go ahead and use your triangular similarity postulates, which are SSS, ASA, SAS, AAS, and AAA, to show that these are similar. So you're going to have to go, and if you decide to say, hey, it might be best to start off with AAA, but you're going to have to actually go in and measure these angles. Okay? Find what that angle is. Find what this angle is. Does that angle equal that angle? And so on. Then, once you've done that, I want you to start looking at these side lengths. And how can we compare these side lengths? Okay? What you should have at the end of this is, let's say we have some side lengths. I have B1. Okay, that's my altitude. And if I go ahead and just show the label, B1 is right here. Okay, let's see what B1 over D1 is. So I'm going to show D1 as well. Let's just see what that ratio is. B sub 1 divided by D sub 1. Okay, and that gives me a number right here. You can look at the object properties, and it's based on B1 divided by D1. Okay, and right now it's 5.7. So let's find what this side is. Oh, that looks like it's D1. So I'm going to go in my input, and I'm going to D sub 1 equals, and this is B1, but in its own triangle, it is C2. Interesting labeling. So divided by C sub 2. Ooh. Polygon 2. D1. What is my problem here? B1 divided by D2. Alright, so my first number should be this. Okay, and when you're done, you should have that these ratios are the same. As I move this around, even though those numbers change, where did my numbers go? It should maintain the same. So maybe I have to A equals B sub 1 divided by D sub 2, and B equals, what was this? D1 divided by C sub 2. Whoa. Just deleted on me. So B equals D sub 1 divided by C sub 2. Why is it doing that? Oh, there is no C sub 2. There is a C sub 2. So D1 C2. Is there already an object B? There is already an object B, and that's why it's deleting it. So I have to go here, and I'm going to create an object that's not there, Z. D sub 1 divided by C sub 2. Bam. Okay, if you got lost in the end of that, I understand. I will help you out with this. But you'll notice my A and my Z value, they stay the same no matter what. So hopefully this is a good exploration to show that similar triangles work, are created with the altitude of a right triangle. Alright, hope you guys are having a good day, and I'll see you in class.